Hello, beautiful people. A wonderful time. I want to take this opportunity to bring a video to the video on my machine learning project that I've done. It's a famous project. Well, so let me just dive into it right away. So this project, as you can see here, machine learning from disaster. This is a cargo competition project from the Titanic Dataset. So just want to read, let me just go through the project summary here. So the project summary: machine learning from disaster using the Titanic Dataset is a project aimed at using machine learning algorithms to predict the survival of the passengers of the Titanic ship that tragically faced its demise after an unprecedented shipwreck on the fateful day of 15th of April 1912. We remember that we remember very well Titanic, and everybody knows about it. So this is the famous and legendary data set and machine learning project at in Cargo. It's mostly it's the beginner project for the competition. So I actually took time to go through the data set. So basically, let me just show you the data sets. The cargo team, they present the data set. They give two data sets. Here, the one that you can see on my screen now. Just on the third class. Oh my goodness, these guys were not lucky. Most of them had very low chances of survival. Their chances of being drowned was high. Just see, serious. The next thing I did, survival based on sex, male or female, who were highly able to survive. And it is here. You can just get it with your own eyes. The our female counterparts on this Titanic ship, they had the high chances of survival. See, this is now the famous quote that ladies first gets to play here. You can just see now, kind of ladies first. The rescue team seem to really favor the ladies. Then men, they were actually unfortunate here. Uh, they were really unfortunate because most men here, their chances of survival was very low. See, serious. Then, based on embankment, survival based on embankment from where you embarked on. This Southampton, Queensland, or I've just forgotten this sea. No? See me. I'm gonna check it. Mhm. Where they embarked from. So chances of survival for guys from Southampton were really they were really not able to survive. Most of them see. But for let me just check this. Shelburne. Yeah, Sieves guys from Shelburne. Their chances of survival was a little bit high than on the rest compared overall. But I think guys from Southampton guys were more than any other guys here. Passengers. So passengers that embarked from Southampton on average did not survive the wreckage. Conversely, from Queenstown, even though their number seemed significantly small, on average, more of them had greater chance to survive the wreckage. So the survival based on title, Mr. Oh, if you are a Mr., the chances of survival are very low. If you are a Miss or Miss and Mrs., they were really on a good side to survive. See the orange bar here. But for the Mr. Oh, This is now the good thing with data analysis. You get to understand it, the real thing. When I just showed you that particular Excel sheet, there's nothing much to see about it. Just see some columns and rows. But now, if you do go read deep into analysis now, we get to understand the meaning of that raw data, because now we are getting inside that. You see, female in that data in this wreckage, in this tragic accident, females were highly favored from surviving. They were highly rescued. But for the male, to survive for the fittest, only the strongest to survive. And then survival based on is alone. So this is now family and sibling. If you are alone, it's a yes. Yes means it's alone is a Boolean attribute. So if one means yes, so if they were alone, there were low chances of survival. If they were family, their siblings and this family, most of them were survived, right? Let's see. So this is also another thing that caught my attention. What about gender? Yeah, so survival rate by gender and class. So we can see female and male. So female, and you can see female, there were higher rate of survival. Survival rate was high. See here on the y-axis. The survival rate was high for female, and for the male, their survival rate was low. And then on the class, female on the first class were highly rated as well. Even the second class. This is how it was here. That is now box plot and history. Survival by age by survival, age by distribution, survival by class and gender, class and gender, male and female. You see, still repeating the same thing that I just done. You see how the male counterparts here, the chance of survival was very low, but for female, you see the orange mark, the chance of survival was high. The same thing here. So again, the scatter plot here. Scatter plot here as well just depicts the same thing. Female were highly favored to survive, as well as this correlation matrix. The correlation matrix as well tries to reveal how each feature relates to each other. Then the next thing here is to pair plot for survive versus fair and family size. Then from there now I did data preparation for machine learning algorithm. Yes, I said I'll use logistic regression, decision tree, support machine, SVM, and random forest models. So preparing the data, and because sex column was male and female, so I want to turn it to categorical, where I actually do encoding where I code male to be 0, female to be 1. Same for encoding impact and title. The next thing is now fits the model, and the accuracy is 85% accuracy. performance. So let me just read this particular summary. The logistic regression, which is the baseline model, already performs quite well. It has an overall accuracy of 85%, meaning it's able to classify a passenger as survived or not accurately 85% of the time. For class 0, the negative class, it has a precision and recall of 86.91%, meaning it has accuracy of 86% in finding the died passengers, and in so doing, 91% of its predictions are actually the died passengers. For class 1, the positive class that survived, it has a precision and recall of 84 and 77% respectively, meaning it accurately identifies the survived passengers with 84% accuracy. However, when it does so, it turns out that its identification are correct 77% of the time. That is the explanation of the confusion matrix, this particular thing here. So, and then I did the visualization of the confusion matrix. You can see the false positive, true negative, true positive. This side is true positive. This is true negative. This is false negative, false positive here. And now I just now delve right into training. So right away, right into training, where now I just deal with the the next one is decision tree, and decision tree performs quite lower than the logistic regression, performs accuracy of 83. For random forest, accuracy of 82, performs quite lower. I think it's because the random forest algorithms are very much powerful, most advanced algorithms in machine learning, and they are able, mostly they are made for very complex data sets that have what can I say? They have a lot of features, and then huge data set, and then they are also data sets that are not linearly correlated. So like this data set for Titanic, it's just a very small data set, and the features are it's a kind of a linear data. That's why logistic regression performs much better with it. And then the random forest classifier doesn't scale well with it. But of course, just tried around 82, that's not quite well. Then now I used random forest. I wanted to find feature importance, which are the features that are important, that are most useful for the prediction. You can see fare, age, title, Mr. then sex, then passenger class, then family. These are the most important features that are used for making the trees for the random forest. Random forest just but an ensemble of trees, many decision trees. So the most important features that help in growing the trees are fare, age, which means these features leads to a reduction in impurity, while developing the random forest classifier. So let me just read the result here, what I got. The random forest decision tree does not perform well as compared to logistic regression. This is why, because the dataset is small and simple, features are mostly linear and low noise. Default random parameters may not be optimal. So the next thing, I tweaked the random classifier model by performing a parameter tuning. Yeah, I did the parameter tuning, but it was still the same result that I got. So 82% accuracy. It was kind of nothing good, nothing improved. But then I tried now to do an SVM classifier here with the kernel to be poly, and it's kind of let's see the results. It kind of, I didn't outperform the random the random forest. It's kind of almost the same as random forest, but at least it has tried it. That's best out of the four more classifier, the four models. The one that has performed very well is logistic regression. That is quite interesting here, but it's because of the data itself. I think if it were such a maybe a complicated and complex data, random forest and decision trees could have performed much better than logistic regression. Here is the report here. I won't read it. It's just very interesting. Improving. Then I tried to improve the performance of the logistic regression, but it turns out that it's just the same result that it brought out. Actually, it even actually did a little bit 85. Yes, actually just the same result. Yeah, this same 85. So I think this data set is not that very much elaborate, but that's why it's not performing very well with the random forest and decision tree. I also tried to do cross validation using decision tree, and the result, like you know, this it wasn't that much better than the original. No, it's just 83%. So actually, just maybe 1% increment that didn't make much change, but it's appreciable. The next thing now is use make prediction on the test set. The machine, the Google, the kaggle. They brought us two datasets, the one for test, the one for training. So now I'll use the training one to make predictions, and then save now into Titanic submission .csv. So actually I saved it. So I just want to show you, I made a prediction on the data and then saved it as a CSV file, and I want to just show you it right away here. It's also very interesting. I was very happy when I saw that it has done a lot of predictions on it. So this is now right on my screen here. It's now the result after training. So and then I did prediction. So passenger 892, the model predicts that he didn't survive. Passenger 893, he survived. You see, 894 did not. So these are the results of my prediction after building the model. I used logistic regression. Yeah, the performance of logistic regression, the accuracy was 85%, and you see it has actually done its best in predicting the survival of this particular passengers. So this in a nutshell has been the report on this project of machine learning from disaster from cargo using the Titanic dataset, the famous Titanic dataset. So I think you have enjoyed and you have got some insight as well as I have. Thank you so much for listening, and see you next time.